Hey everyone, it's Bradley Bush with another algebra video for you. Today we are talking about solving radical equations. Well, what is a radical equation? A radical equation is an equation that has variables which appear in radicals. And oftentimes in algebra you'll just see a radical equation in one variable, which means you just have a single variable like x. Any real number that's represented by x that makes the equation true is called a solution. Here's some examples of some radical equations. So for example, the square root of x equals 9. There's a radical equation for you. How about the square root of quantity 2x minus 1 plus 2 equals x? There's another example. You could also have more than one radical in the equation. Here's an example of one that has more than one radical. So you have the square root of the square root of 3x plus 1 minus the square root of x plus 4 equals 1. If this is the first time to my channel, thanks for coming. Hope you enjoy it. If you do, please consider subscribing to the channel. Give me a thumbs up or leave a comment. Let's talk about how you solve a radical equation. Well, we use the rules of algebra to get rid of the radicals, and then we isolate the variable. In other words, we solve for the variable. Once we solve for the variable, we also need to check the answers to make sure that we don't have to kick out our answer because of a domain restriction or because maybe it's an extraneous solution. An extraneous solution, by the way, is a solution that is created. It's a fake solution. It's not real. It's not valid, I should say. It's not a valid solution. It's one that is created through our solution process. And if the equation cannot be solved, or there isn't a solution, then we see the solution is the empty set. And we write the empty set with this 0 with a slash through it. Here's some steps to help you solve the radical equations. The first step is you need to isolate a term with a radical. You may have more than one radical in your equation, so you might have to repeat this process, but it's okay. Just pick one of the radicals, get it to one side of the equation, get everything else to the other side of the equation, and then you move on to step 2. Step 2 is you square both sides of the equation. That is if you're dealing with square roots. If you're dealing with cubed roots, you cube both sides of the equation and so forth. If you're dealing with fourth roots, you raise both sides of the equation to the fourth power and so on. Then you simplify, meaning you might have to do some more simplification because you've gotten rid of one of the radicals and you look to see if there are any other radicals still there. If there are still radicals in the equation, then you move to step 4 and you repeat steps 1 through 3 until all the radicals are gone. So you generally get rid of one radical at a time. Sometimes you get lucky and you get rid of 2 radicals at the same time, but often you just get rid of 1. So if you've got multiple radicals, sometimes it takes multiple passes through this to get rid of all the radicals. But then once you have gotten rid of all the radicals, by isolating them each separately and then squaring both sides of the equation, assuming you're using square roots, or you have square roots in your equation, then you solve for x, or whatever your variable is. Then the last thing you need to do is you need to check your answers for invalid or extraneous solutions. Extraneous solutions are solutions that appear they're not valid, and they appear or introduced into the system by the process. When we square both sides of the equation, we get a fake answer sometimes. So check for those. Let's solve a radical equation. Our first equation here is square root of quantity 3x plus 18 equals x. Lucky for us, everything is the radical is isolated, meaning it's just by itself on the left side of the equation, and everything else is on the right side. So now the next step would be to square both sides because we're dealing with a square root. So these square and the square root cancel, and we are left with 3x plus 18 equals x squared. Now we've gotten rid of all the radicals, so now we just solve the equation. It's all simplified. There's nothing else we really do. We just need to solve the equation. So let's get everything to one side. Let's bring the 3x over and the 18 over by subtracting them off of the left and bringing them over to the right. And we can see that the 3x cancels and the 18 cancels on the left. So we now have 0 equals x squared minus 3x minus 18. So we need to factor this. Factors of negative 18 that add to negative 3. That would be negative 6 and positive 3. When we solve both of these, set both of these equal to 0, we get x minus 6 equals 0. Take the negative 6 to the other side, and we get x equals positive 6. There's one answer. Now we do that for x plus 3 equals 0. We subtract 3 on both sides, and we get x equals negative 3. So we have two solutions here, and we need to check both of them. Let's check x equals 6. And we check by plugging them back into the original equation. So we have 3 times 6 plus 18 equals 6. So 3 times 6 is 18. 18 plus 18 is 36. So we have the square root of 36 equals 6, which is valid because the square root of 36 is 6. So that's a valid solution. Now let's check x equals negative 3. And we get 3 times negative 3 plus 18. That's all under the square root. And that equals negative 3. So 3 times negative 3 is negative 9. Negative 9 and 18 give us negative 9 and 18 give us positive 9. Square root of positive 9 gives us 3. And that is not true, right? 3 does not equal negative 3. So x equals negative 3 is extraneous. It is a fake solution. It's not a valid solution. So we don't use it. This one's no bueno. So our only solution then is x equals 6. That's our solution. Let's move on to our next problem. Our next problem is quantity 2x plus 15, all underneath is square root, minus 6 equals x. So our first step will be to isolate the variable, or the term that has a radical. So we need to add 6 to both sides, and that cancels the negative 6 out on the left. And now we just have 2x plus 15 still underneath the radical on the left. And this equals x plus 6. We've isolated the term with the radical, and now we can square both sides because we have square roots. This square and the square root cancel, and we're left with 2x plus 15 equals, and this x plus 6 squared, that's really x plus 6. Well, it's a really terrible 6. Let me fix that. Times x plus 6. So if we multiply that out, it's kind of like a foiling problem. Then we get x squared plus 6x plus another 6x, which gives us 12x. And then 6 and 6 give us 36. So now we can simplify. Let's take everything to one side. So let's take the stuff on the left to the right. So we're going to subtract off a 2x, and we're going to subtract off a 15. So the terms cancel on the left. We're left with 0 equals x squared, and 12x minus 2x is 10x. And 36 minus 15 is 21. Now we just need to factor. And we need to find factors of 21 that add to 10. My guess is it's 7 and 3. Now we can take each of these terms that x plus 7, each of these factors, and set them equal to 0 and solve. When we put x plus 7 equal to 0 and solve for x, we can take the 7 to the other side and it becomes negative, and we get x equals negative 7. There's one answer. And our second answer, x plus 3 equals 0. If we take the 3 to the other side, what I mean is we subtract 3 on both sides, and it cancels on the left. That gives us x equals negative 3. So there are two answers. We need to check both. So let's check x equals negative 7 first. If we're plugging it back into the original, 2 times negative 7 plus 15 minus 6 equals negative 7. 2 times negative 7 is negative 14. Add 1, it gives us square root of 1. Minus 6 equals negative 7. Square root of 1 is 1. 1 minus 6 is negative 5. And that does not equal negative 7. So this one does not work. This is extraneous. Let's check x equals negative 3. Let's see, 2 times negative 3 plus 15. That's all underneath the radical. Minus 6 equals negative 3. 2 times negative 3 is negative 6. Plus 15 gives us 9. Root 9 minus 6 equals negative 3. Root 9 is 3 minus negative 6, which gives us negative 3, which does equal negative 3. That one checks out. That one's real. So the only answer here is the x equals negative 3. The other one, x equals negative 7, is extraneous. Let's move on to another one. Here we have one that has 2 radicals. So for the first time, we'll get to see what happens when we have 2 radicals. And I don't think that this radical is going to go away when... I don't think we'd get lucky, is what I'm trying to say, and we're going to kill both of the radicals at the same time. I think we're going to have to repeat the process, so we'll see how it goes. Let's just take the first one. So the equation is x minus 5 underneath the square root minus another square root, which has x minus 8 inside of it, and that all equals 3. So let's take the x minus 8 underneath the square root and take it to the other side. So we're going to add x minus 8, square root of x minus 8 to both sides. And we get, I'm going to move over to the left a little bit more here. X minus 5 root equals 3 plus x minus 8 root. We've isolated the radical x minus 5. So now we can square both sides. Again, because we're dealing with square roots. Now, on the left, things work out great because we have the square root and the square that cancel. On the right, we actually have a problem, a foiling problem. So our foiling problem, let's just do it here. 3 plus radical x minus 8 times 3 plus radical x minus 8. We get 3 times 3, which is 9. We get 3 times root x minus 8 plus 3 times root x minus 8 plus x minus 8 inside of that root squared. So it's just a foiling problem, right? And we have first, outer, inner, last. 3 times 3 gives us 9. And we have 3 root 8 minus, or x minus 8, and another one, so that gives us 6 total. Whoops. 6 times x minus 8. And then we have x minus 8 inside of the radical, and the radical cancels with 2, so we just have x minus 8. Let's put that over here now. So now we know what we have. We can do a little more. Let's simplify a little more. The 9 and the negative 8 just give us 1. So we have 6 root x minus 8 plus x plus 1. So that's what we are going to bring over here. So on the right-hand side, we have 6 radical x minus 8 plus x plus 1. All right. Well, we got rid of one radical of the 2. We just have one left, right? We just have one more. The 6 radical x minus 8. So let's do some simplifying and get everything to one side and keep that radical 6 times x radical x minus 8 on the right. So I need to subtract x and a 1 on both sides. The negative, or the x and the 1 cancel on the right, and we're left with, oh, look at that. The x's cancel on the left as well, so we get negative 5, negative 1 gives us negative 6 on the left. On the right, we have 6 radical x minus 8. Let's divide away the 6's. It's going to be nice. The right 6 goes, and then we just have 1. Negative 1 on the left. So that gives us negative 1 equals radical x minus 8. Now we square both sides. And we get 1 equals x minus 8. And I can easily solve for x now by adding 8 to both sides. And I get x equals 9. So now I need to check this. And my original is 9 minus 5 minus 9 minus 8 in the radical equals 3. So 9 minus 5 gives us 4. So we have root 4 minus 9 minus 8 is 1. Root 4 is 2. Root 1 is 1. 2 minus 1 is 1. Does 1 equal 3? Nope. So x equals 9 is extraneous. It's an invalid solution. And that was the only one we had, and it was extraneous. So that means our solution set is the empty set. That 0 with a slash through it. There is no real value x that will make this equation true. Sometimes that happens. It's okay. We get over it. All right, here's our last problem. This one looks kind of nasty, right? We've got kind of a radical inception. We've got a radical within a radical. So on the left-hand side, we have radical quantity 1 plus 4 times radical x. That's all inside the radical. And then on the right-hand side, we have 1 plus, and then we have a radical x. So it looks like we already have, I'm just going to square it right away because the big radical on the left is already by itself. So we can see the radical and the radical cancel, the outside radical. So we're left with 1 plus 4 radical x. And we have another foiling problem. Let's work that out here. 1 plus radical x times 1 plus radical x. That gives us 1 times 1 plus root x plus root x plus root x squared. So, well, that's not a very good equal sign. So that gives us 1 plus 2 root x plus x. Okay. Let's bring that over. 1 plus 2 root x plus x. Okay. Well, let's get everything with a radical to one side and everything else to the other side. So let's subtract a 1 on both sides. And luckily for us, that 1 cancels and completely goes away. Now we're left with 4 root x equals 2 root x plus x. Let's subtract a 2 root x on the right side, well, on both sides actually. We're taking that 2 root x on the right over to the left. Cancels on the right. And we had 4 originally, we take 2 away, so we're left with 2 root x. And that equals just x. All right. Well, now we can square. We've isolated the radical and we can square. So when we square on the right, on the left, we square the 2 because this is a product, so we square everything inside. So we square the 2 and we get a 4. We square the root x and the square and the root x cancel, and we're just left with x. So we have 4 times x equals x squared. Let's get everything to one side. We have 4x equals x squared. Let's subtract 4x on both sides. Cancels on the left, and we get 0 equals x squared minus 4x. We can factor out an x. We get x minus 4. This all equals 0. Set both these equal 0. We get x equals 0 as one option. Our second option, x minus 4 equals 0. If we solve for x, we add 4 to both sides. That gives us something in blue. X equals 4, our second option. So we just need to check both of those and see if they both work. Let's check x equals 0 first. So we have 1 plus 4 root 0. That's all underneath a radical equals 1 plus root 0. Root 0 is 0, so 0 times 4 is 0, so we get root 1 equals 1. Root 1 does equal 1. That one's valid. So we have checked x equals 0. That's a valid solution. Let's check x equals 4. We get 1 plus 4 times root 4. All of that is underneath a radical. And we get 1 plus root 4. Root 4 is 2. 2 times 4 is 8. 8 plus 1 on the left underneath the radical. And we get 1 plus 2, which is 3. So we're getting close here. 1 plus 8 is 9. So we have radical 9 equals 3. Radical 9 does equal 3. So 3 equals 3. That is also a valid solution. So lucky for us, this one, both of these solutions were valid. So x equals 0 and x equals 4, both are valid solutions to our equation. That's it. Hopefully this was helpful. Hopefully you learned a little bit about solving radical equations, and hope you enjoyed it.